Hi everyone, can you hear me? Okay, that's good. Again, I'm so sorry for being late. I already got caught up in the previous meeting. Okay, let's start the tutorial today. I don't think there is too much theory that I should go over with you. The first one is combination with repetition. Rather than giving you the formula, I think I can show you how to solve that kind of problem directly. So we will not go over the theory for the first one. For the second one, the binomial theorem, the only formula that you need to remember is this one here. So you have a plus b raised to the power of n. You can just have n choose k, and then a to the power of k, b to the power of n minus k, and your k will range from 0 up to n. If you find it a bit difficult to remember, I can definitely post a combinatorial proof later for this quantity. Or another way you can do is you can start with the familiar exponent that you know, for example, like a plus b to the power of 2. Then we know this a squared plus 2ab plus b squared, and you try to bring this one into the form that you are having here. So this is just 2 to 0, which is 1, times a to the power of 0, and then b to the power of b minus 2 minus 0, and then 2 choose 1, a to the power of 1, b to the power of 2 minus 1, plus 2 choose 2, a to the power of 2, and b to the power of 2 minus 2. And you will see here this term is 1 times b to the power of 2, which match with this term that you already have. The middle term is just 2ab, so it match with the middle term that you're having here. The last one is 1 times a squared, which match with this term. Okay. And you can do the same thing for a plus b to the power of 3 to the power of 4 or any exponent. Any question about this formula? You should really know this. This will come again later in the course when we talk about random variable. If there is no question, I want to start question 1. I will guide you through this, and then we need to do proofs with binomial theorem. Maybe, but it should be straightforward. We don't do any rigorous proof in this course. I think every proof that you might need to do is very straightforward and intuitive. Yeah. Okay, so let's start with question 1. I will guide you through this, and then I will give you time to think about question 2, which is in the similar category of question, but it just have more restriction. Okay, so here you want to find the number of non-negative integer solutions to this equation. So one of the solution you might come up with is x1 equal x2 equal x3, x4, x5, and equal to 2, right? Or you can have like x1 equal to 1, x2 equal to 3, and then x3 to x5 equal to 2. So why does this relate to combinatorics that we are talking about? The thing is because each xi, you can think of it as a bin. Let's say it is a bin holding the number of like the amount. Let's say you want to distribute 10 balls. Then in each bin, you will put some amount of balls in, and that amount will never be negative. it will always be at least 0. So for example, the first case here, when you have x1, x2 up until x5 equal to 2, it is the same situation as you putting 2 balls in each bin. Does this step make sense? Yes, and then, for example, if we are talking about this way of distribution, where x1 is 1, so x1 only have 1 ball inside it, but x2 equal to 3 mean that inside x2, we will have 3 balls. And from x3 to x5, we will have 2 balls each. Then you can think that the sum that you want to achieve here is the amount of balls that you want to distribute, and the balls are identical, which means we don't care that the first ball go in here and the second ball go in here, or the second ball go in here and the first ball go in here. It is not different because the balls are identical. So here is a problem of how many ways are there? We can distribute 10 identical balls into 5 bins like this. So from this problem, we convert it to this problem. Does this step make sense, or anyone have any question? Please make sure that you understand everything here. If you are shy, you can just direct message me, so I'm the only one who can see your message and not your peer. That was so fine. And from this one, it is 5 to the power of 10. Why do you think so? Why is it 5 to the power of 10? If you do like, okay, how many choice are there? I can put this ball in. I have 5. How many choice are there? 5 like this, right? But that is the case when your balls are distinct. Because it take into account that, okay, this ball go to the first bin and this ball go to the second bin are different distribution from this one going to the second and this one going to the first, right? So that's when the balls are distinct. But here the balls are identical. So the number of ways that we can distribute is actually less than 5 to the power of 10. I don't know if you realize that, but this is very similar to the gift problem that we did last time. I believe it was question 1 on Monday tutorial as well. It's very similar. So here we want to distribute 10 balls into 5 bins. So how can we represent that? Instead of drawing the 5 bin, we can use the divider to represent each bin, right? Instead of actually drawing the bin, now I just draw the divider to say that, okay, this is the first bin, and after the first divider is the second bin, after the second divider is the third bin, something like that. So this kind of representation is the same as this kind of representation, right? Any question about this one? And then we will see that the number of ways that you can distribute the ball into those bins is just the number of ways you can arrange these characters. Because if you move the position of the divider, then you will have different distribution. This distribution is corresponding to 2 balls in bin 1, 2 balls in bin 2, and up to bin 5. Or if you put all the balls first like this, and then like this, then what does it mean? It means that you put all 10 balls in bin 1 and you put 0 ball in bin 2 0 ball in bin 3, and 0 ball in bin 4 or 5. And this would be equivalent to x1 equal to 10, x2 equal to x3, equal up to x5, and equal to 0. So each arrangement of this sequence corresponds to one kind of solution, non-negative integer solution. You can get to this equation. So I'm having the answer from student here, 14, choose 4. Yes, that makes sense because the number of ways that you can arrange these objects is you have 10 balls, right? And then you have 4 dividers, which means you have 14 objects in total. Out of that, you have 10 balls, so they are the same types. You have 4 divider, they are another type. So the number of ways you can arrange them is 14 factorial divided by 10 factorial divided by 4 factorial. And this is equal to 14 choose 4 or 14 choose 10. If you write any of the answer here, it will be correct. Is there a way to use combination with repetition formula? I don't remember exactly that formula, but I'm pretty sure that is about this one. Let me just check with your book. Is it 2.4? N of 2.4. Let's see. Yeah, I see a student put the image here for me. Number of combinations of K elements among N with repetition. Yes, so if you use that formula, your N will be 5 and your K will be 10. Because you are trying to form a combination of 10 balls among 5 beams. So if you use that formula, then N will be 5 and K will be 10. I think you meant to flip it. I think this one is the number that I meant, because if you try to plug it in the formula that you sent, you will see that you get these two. N equal to 5 plus K is 10 minus 1, and then choose K, which is 10. Then you will get 14 choose 10. Isn't K less than or equal to N? Well, let's see. I don't think so. Where did you get that restriction? They only say that N is at least 1 and K is at least 1. This is not N choose K. This is not like totally combination. Like for the N choose K like this, then yes, we need K to be less than or equal to N. But this one, I believe there is no restriction on N and K. They just need N is at least 1 and K is at least 1. Does this make sense? Yeah, like you can go with the formula for sure if you want, but I'm just not a formula person. I'm really bad at memorizing stuff. That's why I always convert it in this way. Also, sometimes students mess up between N and K. What is N? What is K? And if you choose the value incorrectly, you will get incorrect answer. So that's why I just don't memorize formula. And instead I go with this way. Then when you can reason about stuff logically, you cannot get it wrong. Okay, so this part here is the final answer. Now I will let you work on question 2 by yourself. It's very, very similar. but it has some restriction here. So you will have to think about it. How do you make sure that each x is at least some amount? You will have to think about that. I will give you 5 minutes and then I will take it up. If you have any question, feel free to put in the chat. Anyone got the answer? 37 choose 2 or 37 choose 35. It looks like a correct one, but I didn't calculate. So let's see. So here you want to make sure that x1, okay, I see another student got this. It's very similar to the first student answer. So if you guys got the same answer, probably they are correct. Let's see. So here you want to make sure that the bin one has at least 0 ball. So we don't have to perform any action to make this true, because when you distribute the balls into the bin, for sure each bin will have at least 1 ball. And then x2, you want at least 5. How do you make sure that they will have at least 5? It is you put 5 balls in here. You just put 5 balls in there first, so that you can satisfy the second condition. The third condition, you can just distribute 10 balls into the third one to make sure that there will always be at least 10 here. So you satisfy the third condition. And we want to satisfy the first one, which is the number of balls in bin 1 plus the number of ball in bin 2 plus the number of ball in bin 3 has to add up to 50. So after you distribute 5 balls in bin 2 and 10 balls in bin 3, then the remaining balls is 50 minus 5 minus 10, which is 35 balls. So now it is a problem of how many ways are there. You can distribute 35 identical balls into 3 bins. So you can use 2 divider to separate 3 bins, and then you have 35 identical balls. So the number of ways you can arrange this sequence is 35 balls plus the 2 divider. And then you choose the position for 2 divider like this. Or you can also choose the position for the 35 balls. Or you can just do permutation with multiset. You have 35 plus 2 elements in total, whereas 35 is of the same category balls and 2 is of the same category divider. So all of those answers are acceptable. I will highlight it. Any question about this part here? If there is anything that doesn't make sense, please let me know. If not, then I will let you work on question 3. Maybe 5 minutes. Keep in mind that we want to identify the coefficient of the term that does not involve x. So you have to look at the power of those. When do they cancel each other out, such that you don't have the term x at all. If you have any question, feel free to put in the chat. Okay, let's look at the first one. If you use the formula here, then you have A is 2x squared. And your B is the whole thing here. Do not like exclude the minus side because in the original formula you have plus. So in here you have plus negative something. So your B will be negative 4 over x cubed. Any terms when you expand this, any terms will have the form 15 choose k. A here is 2x squared to the power of k, and your B is negative 4 to the power of x cubed times k. Sorry, to the power of k like this. Because you have n is 15. Okay. Any term when you expand this expression will have this form. However, you are looking for the constant term. Isn't it to the power of 15 minus k? Oh, yes, yes. Thank you. Is 15 minus k? That's correct. And we are looking for the constant term, which means that we don't want it to involve x at all, right? So if we write this out more explicitly, in case you cannot see it, we will have x to the power of 2k and then negative 4 to the power of 15 minus k, x to the power of 3 multiplied with 15 minus k. When can we get a constant term? Is when we don't have any x appear in our expression anymore, right? And it happened when these two terms cancel each other out. Imagine if these two terms are equal and you can cross it out, then the whole term doesn't involve x at all, and it will become a constant term, which means we have to calculate for what is the value of k, such that this one is equal to this one. So I will have to solve for k such that x to the power of 2k is equal to x to the power of 45 minus 3k. And this happened when 2k is equal to 45 minus 3k. Because we have the same base, so we can just kindly remove that so we can deal with easier math. And now I will bring minus 3k to the left-hand side. And you will have 5k equal to 45, which means k is equal to 9. So when k is equal to 9, these two terms will cancel out, and you will be able to get the constant term. So the constant term is when k equal to 9. So I will have 15 choose k is 15 choose 9, 2 to the power of 9, negative 4 to the power of 15 minus 9. And I believe that in the exam, you will have calculator and you will be able to calculate this quantity. Any other question about this one? How did I find it? For part 2, you can do exactly the same thing, but you will get k is equal to 6. I will leave this as an exercise for you because it's very similar to part 1. If you understood what I did in part 1, you can do part 2. If there is no question, I want to move on to question 4. I will give you again 5 minutes. This is a bit more difficult than what you did in question 2. For question 2, you only have this restriction, but now you have the upper bound restriction as well. one formula you might want to use is how to calculate cardinality of union of three sets. I will write it out for you. Yeah, and think about it. You should start with something that you did in question 2 and try to build up based on that. Okay, so here, let's start with what we did in question 2. Let's just consider the lower bound condition. So the number of, here I mean non-negative, I miss it. Non-negative integer solution if we only consider the lower bound, so we need to make sure that x is at least 0, x2 is at least 5, and x3 is at least 10. We can grab the answer that we got from question 2 because it's exactly solved. X1 plus x2 plus x3 equal to 50, where x1 is at least 0, x2 is at least 5, and x3 is at least 10. We solved for this, and it was like 37 choose 2, I believe. And then from here, you will see that if we consider only possibilities that it satisfy this condition, let's say there is a set of solution such that it satisfies all the lower bound, then what do we have in this set? Of course, we can have the set when x is less than or equal to 15. And then like x2 is less than or equal to 20. x3 is less than or equal to 25. We can have that. So right now we want x1 is less than or equal to 15 and x2 is equal to 20 and x3 is less than or equal to 25. However, you will see that in order to satisfy all three of them at once, to calculate the number of solutions that satisfy that is not straightforward. However, if we can turn it into like x1 is greater than or equal to something, x2 is greater than or equal to something, x3 is greater than or equal to something, our life will be much easier because we can just use the strategy that we did here. So we would want like the greater than or equal form. We don't want the less than or equal form. So we will have to look at the complement. The complement of what we want is that x1 is greater than 15, right? Because the opposite of less than or equal is greater than. So we have x1 is greater than 16. The negation of n is or. x2 greater than 20 or x3 is greater than 25. However, we do want them to be integer. So instead of greater than, I can even use, oops, here I mean 15. Instead of greater than, I can use greater than or equal to, and they would be equivalent because we are only interested in integer solution. Like this. So we have the number of non-negative integers that satisfy the lower bound, which is this. In order to calculate how many of them out of these, how many of them satisfy the upper bound as well, we can just take this number, subtract the cardinality of the complement. Does that make sense? Then just separate into 3 cases, add them together. Yes, but not exactly 3 cases because they are not mutually exclusive, right? x1 is at least 16. There is no guarantee that x2 cannot be at least 21. There's overlapping between them as well, and it's possible. So that's why we call this one the event A. When x1 is at least 16, event B is when x2 at least 21. Yes, I will explain that again. If you think about it, this one is the number of non-negative integer solutions that satisfy the lower bound, right? And I want to find the number of solutions that satisfy both lower bound and upper bound. which means you can think of like X is satisfied lower bound, Y is satisfied upper bound, I want both X and Y. Yes. And this one is just cardinality of Y subtract cardinality of X complement intersect with Y. So that's what we're gonna do. We will calculate this one. I think I kind of messed it up. Here should be X. And this one is the complement of what we want to calculate. So if we can calculate the complement, we can take this number, subtract the cardinality of the complement. So the complement is cardinality of A union with B union with C, right? Because we want the word or. So it is union. And if I apply this formula, I will be able to calculate this quantity. I will not solve everything here. I will leave it for you, but I will go over how to calculate cardinality of A. A is when X1 is at least 16. And I do want them to satisfy all the lower bound here as well. So in order to solve for cardinality of A, I need X1 plus X2 plus X3 to be 50. And then X1 is at least 16. X2 is at least 5 and X3 is at least 10. And if I solve for it like I did in question 2, I believe, then I would get 19 plus 2, choose 2. Because you first distribute 16, 5, and 10 balls into each bin, and you would be left with 50 minus 16 minus 5 minus 10, which is 19 balls to distribute. And you have 3 bins, which means 2 divider. So that's why the number of elements that satisfy X1 at least 16 and other lower bound will be this. And you should get the same number for cardinality of B and cardinality of C as well. Next one, if I want to calculate cardinality of A intersect B intersect C. Sorry, not intersect C yet. I want X1 plus up to X3 equal to 50. I want to satisfy A, which means I want X1 is at least 16. I want B, which means X2 is at least 21. And X3, I keep the old lower bound, which is just 10. And you should get 3 plus 2, choose 2. Yes, this is of course not straightforward question, but then once you got it, it kind of become computational thing. You don't really have to think much, to be honest. And then you will see that A intersect B intersect C is 0, because there's no way you can satisfy all 3 conditions. If you satisfy all 3 conditions, then there's some exceed 50. So that's why cardinality of A intersect B intersect C is 0. And here it would be cardinality of B and C, A and C as well. You just need to figure it out by yourself, and you should get the same number with me. And then you plug everything back into this step to calculate cardinality of union of 3. And then the final answer, I will write here for you, final answer. You will take the number that satisfy lower bound, 37, choose 2, subtract the cardinality of this, So I want to subtract this one 3 times. And then I want to add cardinality of the intersection. And then if I subtract cardinality of triple intersection, then it will be 0. Do you want me to like write a formal solution for that? Okay, yes, I can post it later. If I don't, just remind me because I might forget. Is there any other question regarding this? If no, then it is the end of our tutorial. I will see you again next Monday. Have a good day, everyone.